Another flip-flop conversion I'm taking here, SR flip-flop to JK flip-flop. Here the available flip-flop is SR flip-flop and the required flip-flop is JK flip-flop. I think already I have explained how to convert SR flip-flop to JK flip-flop in JK flip-flop explanation. So to convert SR flip-flop to JK flip-flop, S input requires one AND gate externally and R input also requires one AND gate externally. So now I will explain that procedure, how to convert SR flip-flop to JK flip-flop. So in the JK flip-flop explanation, I wrote directly the diagram. Now here I will explain the complete procedure. So based on the flip-flop conversion procedure, first of all we have to write a characteristics table of required flip-flop. Here the required flip-flop is JK flip-flop. So first of all, prepare characteristic table of JK flip-flop. Now, so this is comes under characteristics table of JK flip-flop, that means required flip-flop. So already we know the complete table operation. So directly I want to write those combinations. If J is 0, K is 0, it maintains the previous state. So previous state is 0 and next state is also 0. Both inputs are 0, 0. If the previous state is 1, next state is also 1. And next combination I am taking now, 0, 1 combination. So 0, 1 combination, not equal combination. J and K are not equal, output is follows the input. J input directly, that's why I'm writing here 0. And next combinations are 1, 0 with the previous 0 and 1. In this case also it satisfies the J and K both are not equal. So that's why we can write a J input directly. And the next combination explains both inputs are 1, 1. Previous state is 0 and previous state is 1. In JK flip-flop, J is equal to K is equal to 1. Then the output follows the complement of the previous. So complement of the previous is 0 complement 1 and 1 complement becomes here 0. This is comes under characteristics table of JK flip-flop. Then what is the second step? The second step requires excitation table of available flip-flop. Here the available flip-flop is SR flip-flop. Now I want to draw the excitation table of SR flip-flop from the characteristics table of the required flip-flop. From these outputs, this is comes under present state and this is comes under next state. From the present state and next state, we have tried this inputs, possible inputs. So this is comes under excitation table. This is excitation table of SR flip-flop. Then go through the combinations. Right? For easy understanding purpose, I will write here excitation table representation. And if we just please remember this one, both are 0, 0, S is 0, R is don't care, and Qn plus 1 is 0, 1. Prime state is 0, next state is 1, then S is 1 and R is 0, and prime state is 1 and next state is 0, it gives the reverse of this 0, 1, and both are 1, 1 combination which gives the X 0. This is considered excitation table of SR flip-flop. Now from that, just I want to fill this all this combination. Just go through the 0, 0 combination. 0, 0. So Qn is 0, Qn plus 1 is 0. Then S is 0, R is don't care. Next 1, 1 combination. So 1, 1 combination. S is X and R is 0. So right here S is X, R is 0. X is nothing but don't care combination here. Right? And both are 0, 0. 0x and 1, 0. Then go through this one. 1, 0. If Qn is 1 and Qn plus 1 is 0, then S becomes 0 and R is 1. From that, here I am writing 0, 1. Similarly, the next combination, 0, 1 combination, 1, 0. And 1, 1 combination, again X 0. And 0, 1 combination, 1, 0. And 1, 0 combination, 0, 1. So finally, I prepared here excitation table of SR flip-flop from the output combinations of characteristics table, that means JK flip-flop. Right? Later, write the simplified equation of this S input and R input. That purpose we required K map, because this combination has a don't care combinations, 1 and 0 combinations are there. To simplify the equations of don't care combinations, compulsory we required corner map. So write the corner map for the S input separately and R input separately. First of all, I will prepare the K map for the S input. To prepare the K map for the S input, we have to take the input combinations. JK are the inputs and present state is the Qn also there. So always try to prepare the equations up to Qn variable. So JK Qn, up to you have to take Qn only. So that's why it requires 3 variable K map. So 3 variable K map I'm taking now. For this 3 variable K map, the variables are J, K, Q, N. Just write all these variable names here. Later go through the S input. This K map, this K map is for which input? S input. Then go through this column. In this column here it has the don't care combination, right? So this don't care combination has the input combinations. What are those input combinations? 0, 0, 1. So 0, 0, 1, it gives the don't care here. And again 1 is defined here. That gives the 1, 0, 0, 4. Here 1. And here don't care is there. 1, 0, 1, 5. Here don't care is defined. And again 1 is defined here. 1, 1, 0. So 1 is defined here. 1, 1, 0. And again the 0. Only 4 combinations are there. Now prepare a standard equation for this S input. That purpose, I am taking this one. This one is mapped with this one. This is axis 1 pair. It's axis 1 pair. Then prepare the equation for this. So S is equal to, then go through this, J is 1. So write J as it is. And here 0, 0 is there. Here 1, 0 is there. 0 is common. That's why I'm writing here Qn bar. So to convert SR flip-flop to JK flip-flop, the S input requires this operation J dot Qn bar. So that purpose it requires extra one AND gate. And similarly, I want to prepare the equation for the R also. So this R combination also requires 3-variable K map. Draw 3-variable K map. Then go through the combinations here. R combination, R column. First combination has a don't care. Write one don't care here. And in this combination, don't care 0, 1, 0. 0, 1, 0 is the don't care combination. And one more 1 is defined here. 0, 1, 1. 0, 1, 1 has 1. This one. And again, the 1 is defined here. 1, 1, 1. All ones. So here it has the 1. Now go through that. So finally, which gives the one pair here. This pair. Then what is the equation for this? R is equal to. This pair has K, Q, N. So K, Q, N. Finally, we got the two expressions S and R. Then design the flip-flop. So the available flip-flop should be SR flip-flop. First of all, draw the SR flip-flop. This one is the available flip-flop. Now we have to convert this SR flip-flop into JK flip-flop. That purpose it requires S input is equal to J Qn bar. J dot Qn bar. So it requires externally one AND gate. Draw one AND gate here. This AND gate requires two inputs. One input should be J input and another input should be Qn bar. So already Qn bar is available here. That's why directly I am taking from this combination Qn bar. So Qn bar is connected to the J input AND gate. This one is finished. And later go through the R combination. R requires K dot Qn. K dot Qn. So now draw one AND gate. And the input of this one is K. And one more input should be Qn. Qn is available here. Then connect this Qn directly here. Then which gives the JK flip-flop. So externally this circuit looks like a JK flip-flop. Now so this is the axis JK flip-flop, which consists only two inputs JK and which two outputs, one is Qn and Qn bar. So finally we have converted the available flip-flop SR flip-flop into JK flip-flop. That purpose externally it requires two AND gates. So this comes under flip-flop conversion. Up to now I have explained how to convert one flip-flop to another flip-flop, and now I am going to write the standard equations for flip-flop conversion. So one flip-flop to remaining all other flip-flops. Because just now I explained the standard procedure, follow the same procedure, right? And now I am going to explain how to convert SR flip-flop to, the conversion is from SR flip-flop to JK flip-flop. So just now I explained SR flip-flop to JK flip-flop conversion requires S is equal to JQN and R is equal to JQN bar, right? JQN bar and R is equal to KQN. This part just now I have explained here. And similarly, I want to convert this SR flip-flop to toggle flip-flop. SR flip-flop to toggle flip-flop. So already I have explained one simple technique, the conversion from JK flip-flop to toggle flip-flop. So what is the standard procedure? J and K are short circuited. If J and K both are short circuited, then it is acts as a toggle flip flop. Now I wrote SR flip flop to JK flip flop conversion. So now we want J and K are short circuited. That's why just I'm replacing this J and K by T. That's it. So then finally it becomes a toggle flip flop. So S is equal to TQN bar and R is equal to TQN. Just we have to draw like this, right? So let us take the diagram here. Now I'm taking SR flip flop. The available flip flop is SR flip flop, and clock signal is again connected here, which has two outputs QN and QN bar. Then how to convert into toggle flip flop? Just we want S is equal to TQN bar. So draw one AND gate here, just similar to the JK flip flop conversion. So QN bar is connected here, and again one more AND gate I'm drawing here. This is an AND gate, right? And this QN is connected here, and here we requires J input and here we requires K input in JK flip flop. If J and K both are short circuited, these two are short circuited, then this is acts as a T here. Then the conversion comes under SR flip flop to toggle flip flop. And similarly, now I'm going to convert delay flip flop. SR flip flop to delay flip flop. So how to convert SR flip flop to delay flip flop? Just we want here S and R both are not equal, because already we know that SR flip flop operation. So S and R both are not equal, output follows the S input. That's why here I'm writing S is equal to D and R is equal to D bar. That's it. Now this conversion requires SR flip flop to delay flip flop. S is equal to D. Here connect directly D input to the S input, and R is equal to D bar. That means here connect one NOT gate. One NOT gate is inserted in between S and R, then it is acts as a delay flip flop. So finally, in this slide, just I have explained how to convert SR flip flop to JK flip flop, SR flip flop to toggle flip flop, and SR flip flop to delay flip flop. So I wrote here the complete circuit diagram. And if you want the step-by-step analysis, just follow the standard procedure. Step 1, write characteristics table, and step 2 explains the excitation table. Later prepare the equation and later design the circuit. So finally, I wrote the circuit diagram, right? So just follow the previous steps, then it gives this standard analysis, standard circuit diagram, this one only. And similarly, I want to convert JK flip-flop to other flip-flops. JK flip-flop to SR flip-flop. First of all, I will take SR flip-flop. So if you want to convert JK flip-flop to SR flip-flop, just connect J is equal to S and K is equal to R. That's it. Because SR flip-flop is used in only 3 combinations, and in JK flip-flop, first 3 combinations are similar to the JK flip-flop. So that's why we can write here J is equal to S and K is equal to R. And don't write in this combination 1-1 combination. That's it. So without a 1-1 combination, this is simple conversion. Without S is equal to R is equal to 1 combination. Okay, so 1 conversion is finished. And later I am going to discuss this JK flip-flop to toggle flip-flop. How to convert? I think already I explained in previous video, right? So J is equal to T and K is also T. If J and K both are short circuited, then it is acts as a toggle flip-flop. That conversion also already I have explained here. And later I want to convert this JK flip-flop to delay flip-flop. How to convert the JK flip-flop to delay flip-flop? Insert one NOT gate in between J and K. So J is equal to D and K is equal to D bar. So this circuit diagram also I have explained in delay flip-flop operation. So how to convert JK flip-flop to toggle flip-flop and JK flip-flop to delay flip-flop. So this is comes under JK flip-flop to other flip-flop conversions. Just write the statement here, other flip-flops. Okay, and similarly we have to discuss delay flip-flop too. Delay flip-flop to other flip-flops. Delay flip-flop to other flip-flops means here we have to write delay flip-flop to SR. So let us write here delay flip-flop to SR flip-flop. Which type of conversion is required? Delay flip-flop has only one input, D input. Then How to write the D input in terms of S and R? Write the characteristic equation. So to convert delay flip-flop to any other flip-flop, write the standard characteristic equation, because in delay flip-flop, Qn plus 1 is equal to D. So we have this equation. Delay flip-flop has Qn plus 1 is equal to D. Characteristic equation is there. That's why we can write here directly characteristic equation is equal to D, S plus R bar Qn. Then how is the diagram? Just to go through that. Now I wrote the delay flip-flop. We have to convert delay flip-flop to which flip-flop? SR flip-flop. So it requires one standard equation, S plus R bar Qn. So it requires one AND gate here. This AND gate inputs are R and Qn. See, R bar we require. That's why we have to draw bubble indication like this. And this one is Qn. Qn means you have to connect from here onwards. Qn is already available. That is connected here. And again plus. The plus means we require which gate? R gate. Draw one R gate and connect this combination here and directly S input. Now this delay flip-flop is converted into SR flip-flop. And similarly, I want to convert this delay flip-flop to JK flip-flop. How to convert? Let us write D is equal to J Qn bar plus K bar Qn. This one is the standard characteristic equation of JK flip-flop. So just draw that one. That purpose again I'm taking now delay flip-flop. Then draw D is equal to J Qn bar plus K bar Qn. It requires two AND gates and one OR gate. J Qn bar. So J input I'm connecting here. Otherwise just I want to connect like this. J Qn bar we require. So J input I am connecting here. Qn bar directly connect here. And K bar Qn. K bar. So K bar purpose here, draw one bubble. Draw like this K. Bubble indicates the K bar and dot Qn. So directly connect here. So this is acts as a JK flip-flop. This JK flip-flop designed from the delay flip-flop. And similarly, I want to convert toggle flip-flop now. Delay flip-flop to toggle flip-flop. So to convert delay flip-flop to toggle flip-flop, just write D is equal to T XR Qn, because the characteristic equation of toggle flip-flop is T bar Qn plus T Qn bar, which explains the XR operation. So that's why it requires externally one XR gate. That's it. Before this flip-flop, just I want to draw one XR gate here. This XR gate, one input should be T and another input should be Qn. So finally, this flip-flop acts as a toggle flip-flop. So here I have wrote completely delay flip-flop to other flip-flop conversion processor, right? And similarly, try to solve another flip-flop is there, that is toggle flip-flop. So try to write the standard diagrams of toggle flip-flop to JK flip-flop conversion, toggle flip-flop to SR flip-flop conversion, and toggle flip-flop to delay flip-flop conversion. So please try to solve that to understand the problems. To understand the complete concept, please try to do that.